In this section, we'll talk about present value and inflation. To be able to plan for the future, you have to know how the value of your money changes over time. You're probably all familiar with inflation, which is the rise in prices over time. Present value is the amount of money you need to set aside to have saved a certain amount of money at a specified time in the future. So let's talk a little bit more about present value first. So the present value of an amount to be paid or received at a specific time in the future is what that future payment would be worth today, and that's determined by a given interest rate and compounding period. So here we've got a formula for the present value P of an amount A to be paid T years in the future. And in the first version of the formula here, I've got my interest rate I per compounding period, and N is the number of compounding periods that have passed. In this other version here, I've got this in terms of the nominal annual rate of interest R and the number of compounding periods per year M and the number of years that have passed. Now you may recognize this formula as a variation of the compound interest formula. If you remember, that formula was A is equal to P times 1 plus I to the power N. And here I've just divided both sides by 1 plus I to the N to move that over. So I'm just solving for P here instead of A. So let's take a look at an example of present value. Suppose that the local bank offers a 45-month CD at an interest rate of 2% compounded daily. How much would we need to set aside now in such a CD to have $12,000 in 45 months? So in this case, I've got my nominal annual interest rate of 2% and my compounding period, which is daily. So my R is equal to 2%. I'll put a few zeros out here so that I can convert this to decimal form. So I'm just going to move my decimal point over 2 spaces to the left, and that gives me 0.02 is the decimal form of 2%. Now I know that my interest is compounded daily, so M is going to be 365, so my interest is compounded 365 times per year. And then for T, the number of years that have passed, well, I've got 45 months is the term of my CD, and I want to put that in terms of years. So I'm going to divide 45 by 12 to see how many years that is. And that's going to give me 3.75 years. So now I can just plug everything into my formula. So P is going to be equal to, well, A is the amount I want to have at the end of the 45 months, and that is $12,000. So P is going to be equal to $12,000 divided by 1 plus R is 0.02 divided by M is 365, and then this bottom part is to the power of 365 times 3.75. So if I put that all into my calculator, I need to start out with $11,132.79 in my CD at the beginning if I want to have $12,000 at the end. So that's present value. Let's talk a little bit about inflation. As I said at the beginning, inflation is a rise in prices. So the annual inflation rate A is the additional proportionate cost of goods 1 year later. So if I have some goods that cost $1 in the base year, then the cost 1 year later is going to be given by 1 plus A dollars. So if I have a rate of inflation A, then I can figure out the projected cost in T years of an item with a current cost of P, and that's given by this formula here. So again, notice that this is very similar to the compound interest formula. I've just got an A here instead of an I. So let's look at an example of inflation. Suppose that there is constant 3% annual inflation from mid-2009 through mid-2013. What will be the projected price in mid-2013 of an item that cost $100 in mid-2009? So here I've got my inflation formula. So I want to find the projected cost in 2013, and I know the cost in 2009. So P is going to be the cost that I know in 2009, and that was $100. A is my annual rate of inflation, and that is 3%, so I'll put a few zeros out here. 3%, and I want to convert that to a decimal. So just move the decimal place over 2 places to the left. Gives me 0.03 as the decimal form of 3%. And then T is the amount of time that will have passed. So from 2009 to 2013, that's 4 years, so T is going to be equal to 4. Now I can just plug that into my formula to figure out what the price is going to be in 2013. So that's going to be $100 times 1 plus 0.03 to the power of 4. And if I put that in my calculator, I'm going to get $112.55. So 4 years later, the price has gone up by $12.55. So now we're going to talk a little bit about inflation and depreciation. Because of inflation, the amount of goods you can buy with a given amount of money goes down over the years. I'm sure everybody's experienced this. The relative purchasing power of P dollars in T years from now with an inflation rate of A is how much that amount will buy in T years in terms of today's prices. So if I have P dollars and I want to know how much that's going to be worth in T years, then I can figure that out using this formula. Some items also depreciate or lose their value over time. An item with original price P and a depreciation rate D has a value after T years of A is going to be equal to P times 1 minus D to the power of T. And again, this is very similar to the compound interest formula. I've just got a minus D here because value is going down, so I'm subtracting instead of adding interest. So let's look at an example of depreciation. And one common thing that depreciates over time is your average new car. So if you bought a car at the beginning of 2012 for $12,000 and its value in current dollars depreciates at a rate of 15% per year, what will its value be at the beginning of 2015? So I'm going to use my depreciation formula here. P is going to be the price that I paid for that you paid for the car, which is $12,000. The depreciation rate D is 15%, so I'll stick a 0 out front here. And I want to convert this to decimal form, so I move my decimal point over 2 places, and D is equal to 0.15 in decimal form. And then T is the number of years that have passed. So from the beginning of 2012 to the beginning of 2015, that's 3 years. So I want to see how much the new car has depreciated over 3 years. I'm going to have A is equal to $12,000 times 1 minus 0.15 to the power of 3. So if I put that in my calculator, then at the beginning of 2015, your car is going to be worth $7,359.50. So the value of your new car has dropped a lot in 3 years. The last thing we're going to look at in this section is the Consumer Price Index. So inflation is not generally constant, but it varies from year to year. And to keep track of that, we can look at the Consumer Price Index. This is the official measure of inflation, and it's done by the Bureau of Labor Statistics. So each month, the Bureau of Labor Statistics determines the average cost of some goods, including food, housing, transportation, clothing, and other items. So when they talk about housing here, they're talking about mortgage payments or rent, not the cost of homes. The cost of homes is left out of this calculation. And then they compare this cost with the cost of the same goods in some base period that they've chosen. So we can calculate the CPI for some year by looking at the cost of market goods for that year divided by the cost of market goods for the chosen base period and multiplying by 100. And you can tell that this is a percent calculation, so we're looking at what percent of the cost of goods in the base period is the cost of goods for the other year. So this is a chart of the Consumer Price Index for the past 100 years. Here the base period is 1982 to 1984. So the index for the average of those years, 1982 to 1984, is about 100%. Now if you look at the year 2006, you can see that the Consumer Price Index for 2006 is 201.6. So this means that goods in this period cost 201.6% of what they cost in the base period. So the cost of goods about doubled from 1982 to 1984 to 2006. We can use the Consumer Price Index table to convert the cost of an item in dollars for 1 year to what it would cost in dollars in a different year. So if we know the cost for a year B and we know the Consumer Price Index for the years A and B, then we can figure out the cost of that item in the year A. So let's look at a short example of that. And again, we're going to look at the cost of a car. So suppose I bought a new car in 1996 for $10,000, and I want to know how much would a comparable car cost in 2012. So if I have the cost for the car in 1996 and I know the CPI for 2012 and for 1996, I can figure that out. So I'm just going to plug those in here. The cost of the car I bought in 1996 was $10,000. If I look at my table, the CPI for 2012 is 232.0, and the CPI for 1996 was 156.9. So if I put that in my calculator, I can get the cost for the same kind of car in 2012 would be $14,786.49. And finally, we're going to look at one more example. We're going to look at the price of a house. Now remember, I said that the price of houses aren't included when you calculate the CPI, so we're going to expect that maybe this is not going to be quite accurate. So suppose I bought a house in mid-1992 for $133,000, and that was the median price of U.S. housing at that time. So if I use the CPI what would I get for the equivalent cost in mid-2012 dollars of that house? So again, I'm just going to plug into my formula here. So I know the cost for 1992 was $133,000. The CPI for 2012 was 232.0, and the CPI for 1992 is 140.3. So if I put that into my calculator, I'm going to get a projected home cost of $219,992. So that is what I would expect if I was just looking at the CPI for those years and trying to figure out how prices have increased. In fact, the median house price of existing homes in 2012 was about $178,000, so a lot lower than we would have expected if we were using the CPI to guess. And this is because of course, the housing crisis, and the house prices have not kept up with inflation. So things you should know for this section: you should be able to find the present value you would need to have a given amount sometime in the future. You should be able to find the projected price of an item from a given annual inflation rate. And you should be able to use the Consumer Price Index to convert the cost of an item in dollars for one year to what it would cost in dollars in a different year.